Lesson 5.3, trig with angles greater than 90. Now, this is the first time you guys will have done trig involving angles which are more than 90 degrees. So this is going to be a completely new concept to everybody. You wouldn't have seen this before. So to start off this lesson, we have to look at a few definitions which aren't going to make a whole lot of sense to begin with, but as we progress, we'll kind of tackle each one as we go. So the first one is standard position. The position of an angle when its vertex is at the origin and its initial arm is on the positive x-axis. Initial arm, the ray of an angle in standard position that lies on the positive x-axis. Terminal arm is again a ray of an angle that rotates about the origin, and then a terminal point. So in order to first look at these definitions, we're going to kind of focus on a watch. And I have my wife's watch here, and I'll see if I can zoom in a bit. And if you can imagine that we're looking at time approximately 3:15. So at 3:15, if we don't look at the seconds here, you have the minute hand on top of the hour hand. So you have two arms of the watch sitting directly on top of each other at 3:15. Then what happens is as I move one of those arms counterclockwise, you'll notice that an angle is now formed between those two arms. So we have an angle occurring right here. So this little short arm here that stays at the 3 is called the initial arm. So that stays on the x-axis. This arm is referred to as the terminal arm. That's the one that rotates as we go around the circle. So as you can see, if I continue to rotate this watch all the way around, now if we imagine that this is still pointed at the 3, now I have a huge angle created from here all the way around to this arm. So as the arm rotates, we're creating various angles between those two arms. So again, the initial arm stays at the x, or in this case pointed at the 3. The terminal arm starts on the x-axis, or here at the 3, and that one rotates. And as it rotates, we create an angle, in this case 90 degrees, between those two arms. So initial arm, terminal arm. Now the definition of standard position, that just means that just like a watch, both arms start at the origin. They start at 0. And they both progress along the positive x-axis, right? The positive side of the x-axis. So we're going to draw that down here in this first diagram. So we have the initial arm that sits on the positive x-axis. So right here, I know you're not going to be able to see it real well. We stick an arrow at the end. And then we have the terminal arm kind of as it rotates. So positive x, positive y, initial arm, and terminal arm. And then as that terminal arm rotates, we create an angle between those two arms. Now, under the definitions of initial arm, it says that the ray of an angle. Now, difference between a ray and a line, right? A line is continuous in both directions. A ray has a beginning and only travels in one direction, which is why we are referring to the initial arm and the terminal arm as rays, because they both originate here at the origin and they only travel in one direction. Now, lastly, we talk about a terminal point. The point on a circle that results from forming a given angle. So on my terminal arm, I will have a specific point. And that point sits on a circle. So you can imagine if we kind of hold this line in the center, I put my pen here, and as I travel around, it will create a circle. So we're going to try our best to create a circle. So your terminal arm has a point that we say sits on a circle, because if we continue that around 360 degrees, it would in fact create a circle. And if we take our terminal point and then go down to our initial arm, it gives us a right angle triangle. So underneath that, we're going to say that the terminal arm moves counterclockwise up to 360 degrees, creating a positive angle. So this terminal arm continues moving in this direction, and it can go all the way around to 360 degrees. So on the other little diagram, we're going to do the same thing. I'm going to draw the initial arm on the positive side of the x-axis. So I'll put a little arrow there. Initial arm. And now I'm going to put my terminal arm down here. And now my angle is created in here. And my terminal arm is now moving in this direction. So initially, in my first diagram, we're moving counterclockwise, right? We're moving opposite the direction of a clock. In this one, we're moving in the direction of a clock. We're moving clockwise. So a terminal arm moving in a clockwise direction creates a negative angle. Now, a negative angle, in fact, doesn't actually exist. You can't have a negative angle. It's like you can't have a negative distance. You can't have negative time. You can't have a negative angle. An angle is just an angle. So if you see a negative angle, for example, if we have, say, negative 60 degrees, the negative only implies direction. So negative 60 tells us we're moving 60 degrees clockwise. So we'll make ourselves a note saying the negative only implies direction. So if it's positive, we're moving counterclockwise. If it's negative, we're moving clockwise. Sorry, I'll move that up so you can see it. As well, at the bottom of the page, just as a review from the past, your 4 quadrants, right? Quadrant 1 up here in the top right, quadrant 1, 2, 3, and then 4. And we start off at 0, 90, 180, 270, and then 360. So this lesson is about looking at our angles as we progress through those 4 quadrants from 0 degrees all the way around to 360. So the second page at the top, this is what we just did. So this is quadrant 1. We have our initial arm on the positive x, and we have our terminal arm starting to go counterclockwise. And that creates our angle and in here. That's what we just talked about. Now if we move over to quadrant 2, in this case that terminal arm has now moved past 90 and it's now over here in the second quadrant. When that happens, we actually have 2 angles that are being created. We have this big angle that goes from the x-axis to our terminal arm, And then we also have this little angle here that's created between the terminal arm and the x-axis. So once we go past 90, we're actually having two angles that are being created. The first angle, this large one, is referred to as the principal angle, and the tiny one is referred to as the acute angle. So the principal angle goes from the initial arm to the terminal arm, and the acute angle is the one here between the terminal arm and the x-axis that is less than 90. In the definitions, I made a point to say that the acute angle is always between the terminal arm and the x-axis. We never put it between the terminal arm and the y-axis. So I mean, I'm not putting an angle up here, right? I'm not putting it next to the y. Similarly, here in quadrant 3, I'm not going here next to the y-axis. It's always between the terminal arm and the x. So quadrant 3, and then finally we can finish off with quadrant 4. Now in quadrant 4, they have us going in a clockwise direction. I prefer to stay consistent, and being consistent, we're going to go all the way around and continue in a counterclockwise direction. So once we go past the first quadrant, we're ending up with two angles, the principal angle and the acute. The reason in the first quadrant, you'll notice that they're both the same. The principal angle and the acute angle are the same angle. It's only once you get into the second, third, and fourth quadrants that you have the two angles. Now we're going to kind of go through step by step through all those quadrants. And to start off with, we're going to draw the 30, 60, 90 special triangle. Now, if you remember from lesson 5.2, we drew that triangle. It was the equilateral that we kind of broke in half, right? So we have the 1, 2, root 3. This angle was 60 degrees, and this angle up top was 30. So I'm going to take this triangle, the 30, 60, 90, and I'm going to flip it kind of on its side. Now, we're not going to be super accurate with this. I just want to have a triangle. So we have a right angle triangle. Now, if you imagine we're taking this and we're kind of rotating it downwards in this direction, so this gives us the 30 degrees. This angle is 60. The hypotenuse is 2. This side is 1. And my x is root 3. Now I'm going to take that and I'm going to go from the first quadrant. I'm going to take that and I'm going to do it in the second quadrant. So again, I'm going to take my triangle. I'm going to draw it in the second quadrant. So the angle is still the same. This is still 30. 60 up top. Hypotenuse is still 2. This side is 1. And my x is root 3. Now, we're having the exact same things here in quadrant 1 and quadrant 2. Except there's one big difference. And the difference between quadrant 1 and quadrant 2 is that once you go across that y-axis, and we're over here, we know that the x values become negative. So positive root 3 in quadrant 1. Once you come over to the other side of the y-axis in quadrant 2, my x value now becomes a negative root 3. So we're going to kind of skip ahead to the table on the next page. So in quadrant 1, which was this one, my acute angle is here. So the acute angle is 30 degrees. Which because we're going from the initial arm, or the positive x-axis, to the terminal arm, the principal angle is also 30 degrees. And if I look at my triangle, from the 30, sine opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. So I'm going to come up with my three trig ratios. Sine is 1/2. Cos is √3/2. And tan is 1/√3. And if you remember from lesson 5.2, we can't have a radical in the denominator, so we're going to rationalize that by multiplying the top and bottom by √3. And we get √3/3. Quadrant 2, which we drew here, our acute angle is still 30 degrees. However, our principal angle is from the positive x-axis to the terminal arm. That's my principal angle. So to figure out this angle, we know that with a circle, all the way around a circle is 360. Halfway around a circle, well, it's nowhere close to half. But anyway, halfway around a circle is 180. So from here, from my x to my x is 180. Subtract the 30, gives me the principal angle of 150. And then again from quadrant 2, sine opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. So we're going to use those three values and come up with our primary trig ratios again. So sine is 1/2. Cos, in this quadrant, remember we have negative √3/2. And tan is 1 over negative √3. Rationalize it. So we get negative √3/3. Now, going back to our quadrants, we're now going to go down here to the bottom and look at quadrant 3. So, same thing, I'm going to draw my triangle. Right angle, it's 30, 60, hypotenuse is 2. We know my x is negative √3, right? Because I'm on this side of the y-axis. And similarly, because I'm below the x-axis, this is going to be -1. Now, students always ask, well, what about the 2? Wouldn't the 2 be negative because I'm below the x-axis, right? My x is negative, my y is negative. Why is that 2 not negative? Well, if you remember, this is the hypotenuse, and the hypotenuse can never ever be negative. Because if you think of c squared equals a squared plus b squared, when you take the square root to get your answer, you're always getting a positive value. Hypotenuse can never ever be negative. Because essentially what we're looking at here is just a distance, right? A distance from the origin to this point. So because it's a distance, the hypotenuse always stays positive. Our acute angle stays as 30 degrees. And our principal angle, which starts over here on the positive x all the way around to our terminal arm, will be our principal angle. So again, we're going from x to x. X-axis is 180 plus 30. So 180 plus 30 takes us to 210. So 210 degrees in quadrant 3. So in this case, our sine ratio, opposite over hypotenuse, cos adjacent over hypotenuse, and tan, opposite over adjacent. So sine is -1 now over 2, cos -√3 over 2, and tan is -1 over -√3. Rationalize it. And because we have a negative divided by a negative, it gives us a positive √3 over 3. And we now go back to quadrant 4. So again, starting at our origin, draw our triangle. You notice too with my triangles, I'm always making them with the x-axis. I'm never drawing a triangle this way where I'm touching the y. Everything about this always revolves around the x-axis and not the y-axis. So 30 degrees, 60, 90. Because now I'm back on the right-hand side of the y-axis, I'm back to a positive √3. This is still a -1 because I'm below the x-axis, and the hypotenuse is 2. Acute angle and principal angle. So my principal angle, basically going all the way around to 360, and then coming back 30, means my principal angle is going to be 330. My acute angle is 30. We're in quadrant 4. And in quadrant 4, we'll come up with our primary trig ratios again. The one is negative, so sine is -1/2. Cos is positive √3 now, over 2. And tan is -1 over positive √3. And we end up with -√3 over 3. All right, so what we did is we took that single triangle and we went from quadrant 1 to 2 to 3 to 4. And we looked at which sides were positive and which sides were negative, and we came up with our primary trig ratios. And when we look at those primary trig ratios in that table, what we notice is they're all the same, right? 1/2, √3 over 2, √3 over 3. But what we want to notice is when are they positive and when are they negative? So in quadrant 1, sine, cos, and tan are all positive. In quadrant 2, sine is positive, but cos and tan are negative. Quadrant 3, tan is positive, and in quadrant 4, cos is positive. And the reason why that is important is because it tells us, of course, in which quadrant a specific trig ratio is positive. So if we draw our 4 quadrants, we now have something referred to as the cast rule. C-A-S-T for cast. And what cast stands for is which quadrant is a specific trig ratio positive. So C, of course, implies cos is positive. S is sine, T is tan, and A stands for all. So in the past, all of the trig that you've done in grade 10 involving triangles all took place in quadrant 1, where they were all positive. This year, we're starting to look at triangles with angles greater than 90. So we're looking in this quadrant, or this quadrant, where not necessarily all trig ratios are going to be positive. So quadrant 1, 2, 3, and 4. Trig ratio is positive. Now, you'll see in the next lesson why this is so critical and why this is so important. But this table is just to show you, as you go through each quadrant, how we determine whether sine, cos, or tan is positive for that specific quadrant. So we looked up here and we saw like two angles, like 30 degrees or 150, 30, 210, 30, and 330. So let's take a look at two different angles. So let's go out of that first quadrant. So let's look at the second quadrant and we'll just say, I don't know, let's just choose one. Let's do 126. So if I do the sine of 126, and I grab my calculator here, sine of 126 is 0.8090. So if I'm at 126 degrees, I'll just do a quick sketch here. 126, I know I'm going to be over here between 90 and 180. So this angle is 126, which means that my angle in here must be 180 subtract 126, right? If this whole thing is 180 and I subtract the 126, I'm going to have that angle in there. So 180 subtract 126 is what, 54. So that acute angle in there is 54 degrees. Now if I type in the sine of 54, again, making sure that you're in degrees, not in radians, sine of 54, 0.8090. Which means that because this terminal arm is here, both of those angles are the same. They're identical. So not only do you have the sine of 54, you also have the sine of 126 giving you the same ratio. Now because I'm in this quadrant, sine is positive, which is why we get two positive decimals. But what happens if I try to do, say, the cos of 126? Cos of 126 is negative 0.5877. And the cos of 54 is 0.5877. So for cos, if it's in the first quadrant, 54 degrees, it's positive. But once we go into the second quadrant, you see now how cos is negative. And the same thing would be for tan. If I did the tan of 126, it's going to give me a negative decimal. Tan 126, negative 1.3763. And we know now that if I do the tan of 54, I'm going to get the same decimal, but it's going to be positive, 1.3763. So depending on which quadrant you're in, that's what's going to give you a negative decimal for that specific Trig ratio. Okay, so let's look at one other example. Let's look at, let's go down here. So something between 180 and 270. So let's go, I'll make it 230. I just made that up. So from my principal or my initial arm to my terminal arm, my principal angle is 230. So from 180 to 230 is 50 degrees. So that acute angle is 50. Again, between the terminal arm and the x-axis. I'm not going over here with the y-axis. Terminal arm, x-axis. So if we do, let's do the sine of 50. And we know that's going to give me a negative answer because I'm in quadrant 3. Sine 50, not sine 50, sorry, sine of 230, well, sine of 50 in the first quadrant will be 0.766. So we know the sine of 230 negative 0.766. Cos of 230 negative 0.643. But if we do the tan of 230, we get positive 1.192 around it. So because I'm in this quadrant, CAST, tan is positive in this quadrant, which means I'm going to end up with a positive decimal. Everything else will be negative. So for this lesson, we're looking at the CAST rule and knowing which quadrant a specific trig ratio is going to be either positive or negative. And this leads us into our larger lesson, which is 5.4. We're going to take this, we're going to use it in different situations. So to get your acute angle, depending on which quadrant you're in, if you're in quadrant 1, your angle is just your angle. In quadrant 2, you're going to be doing 180, subtract your angle. In quadrant 3, it's 180 plus your angle. And in quadrant 4, it's 360, subtract your angle. And that's how we determine what your principal angle is, or if you needed to determine what your acute angle is. You'll notice for this lesson as well that there is no homework. That's because this just is just an introduction into 5.4.